As long as you're nice and precise, drawing and naming alkanes and alkenes is very straightforward. There are only two steps you really need to go through. The first one is the number of carbon atoms. Both alkanes and alkenes are hydrocarbons, which means they contain only hydrogen and carbon. So we need to know how we can figure out how many carbon atoms there should be in the carbon chain. And I've gone through this on our video on fractional distillation. I remember a little mnemonic to help me remember: monkeys eat purple bananas. This corresponds to the number of carbon atoms in the carbon chain. So if we have one carbon atom in the carbon chain, the beginning of our word is going to be meth. If we have two carbon atoms joined, it would be eth. If we have three carbon atoms joined together, it would be prop. And if we have four, it would be bute. And the second part of these words is going to be determined by whether it is an alkane or an alkene. The second thing we need to know then is the type of bonding, or the type of bonds. If we have all single bonds, this means we have an alkane. So we simply need to add ane to the ending that we arrived at from the top here. If we have one and only one carbon-carbon double bond, then it's an alkene. And again, the ending we have from the top would then be ene. One way to remember this is to look at the number of e's in the names of these. Okay, in the word alkane there is only a single e, therefore it's going to have all single bonds. In alkene you've got two e's, double e, therefore it's going to have a double bond. So let's go through a few examples of this. Let's just draw, let's draw this one out first. So in this compound here, I've got 1, 2, 3 carbon atoms that are joined, therefore it's going to be prop. I've only got single bonds between the carbon atoms, therefore it's going to be propane. Okay, so this first part comes from the number of carbon atoms, second part comes from whether it's an alkane or an alkene. When it comes to drawing these, I'll go through an example of an alkene as well. If you had, let's do a simple one. If you had this, you've got two carbon atoms, therefore it's going to be eth. You have got a double bond, so it's going to be ethene. Okay, remember double E, double bond. When it comes to drawing these, there's an extra rule we need to know, and that is that every carbon atom must have 4 bonds in total. So if you were asked to draw propene, you can apply the rules we had again. We've got prop, and if we look back, that means it's going to have 3 carbon atoms joined. We've got an ene, so it's going to be an alkene. Remember that we only ever have one carbon-carbon double bond. It doesn't matter which one you put that between, but let's just put that between our first 2 carbon atoms here. So that's our carbon backbone. We then need to make sure that each carbon atom has 4 bonds in total. Okay, at the moment this carbon atom has got 1, 2, because double bonds count as 2 bonds. So we just need to add 2 more bonds in, which we're going to add hydrogens to. This is the one that people often get wrong. This carbon atom at the moment has got 1, 2, 3 chemical bonds. We only need to put 1 more on. So the middle carbon here only has 1 hydrogen, and this end one has currently got 1 bond attached to it, therefore we need 3 more, HHH, and this structure is propene. When it comes to writing the chemical formula of alkenes, it's dead straightforward. With this one we've got 3 carbons and 1, 2, 3, 4, 5, 6 hydrogen atoms. To get from the number of carbons to the hydrogens, you simply double the number of carbons. The general formula is pretty straightforward. It's just CnH2n. So we simply double the number of carbon atoms to get the number of hydrogens. Remember that for an alkane, to work out the general formula, we have to do CnH2n plus 2. One final thing we need to know is how we can actually distinguish between alkanes and alkenes. So for example, if you were given two boiling tubes and you were told that one of them contained a colourless alkane, it could either be a liquid or a gas, it doesn't really matter. Obviously if it's a gas you would have a bung in the top, and your other boiling tube contained an alkene, you would not be able to we would not be able to distinguish between them just by looking at them. They would both be colourless liquids. So we have to use a chemical test to tell the difference between these. And what we use is bromine water, which is just bromine gas dissolved in water. And you would simply add a few drops of bromine water to your alkane. You would add a few drops of bromine water to your alkene. And since the bromine water is orange, it will diffuse through both of the liquids and should, at least for a second or so, turn them orange. And actually with the alkene, the bromine water will react. So it would go orange for an instant, however it would react with the double bond in the alkene, and you would see it turn from orange to colourless. So you have a chemical reaction occurring here, and it's actually reacting with the double bond of your alkene. Okay, so bromine water will turn alkene from orange to colourless. Sorry, let me rephrase that. When you add bromine water to an alkene, the system will change from orange to colourless. It's not the alkene that changes colour, because the alkene is colourless. It's the bromine water that changes colour to colourless. With an alkane, the solution would stay orange. What is actually happening here, you don't need to know this for GCSE, but it's kind of interesting, is bromine is adding across your double bond. Okay, so the bromine can actually break open the double bond, and it will change it to a single bond. And you will have bromine added across that double bond. Okay, so this compound is colourless, this compound is colourless. It's the Br2 bromine water that is orange. And this is actually very similar to the hydrogenation reaction when you harden an unsaturated fat. There you're adding hydrogen across, here you're adding bromine across the double bond.